Good morning. I am back with you in Arkansas. It is a pretty brisk winter morning, mid-January, actually still early January. I got here late last night and the temperature was really a fairly pleasant above freezing. This morning when I woke up, there was a really heavy frost everywhere, and it was probably a quarter of an inch thick on just about everything. The humidity was really high, which isn't unusual for here. The temperature really wasn't all that cold. It only got down to 26 degrees, but it's a brisk morning. I finished unloading my truck from the material that most of it I made on the wood miser in the past couple of weeks. So I'm back to work on the shed. And I don't mean to bore anyone, but I do want to get back to basics here for some of you who may not be aware, or you're in the same situation and want to be able to do things properly. So the first thing we are going to do is to go through here and check the grade, check this for squareness to see if we've got something nice to start from. Let's get started. I have my laser set up, and when you do a laser setup, you want it to be as close to the center of what you're working on as possible. Because if there is any error in the laser, that just gets multiplied from the further away that you get from your work. So I'm set up on the deck here. If I walk in the middle here, I may get a little bit of fluctuation in it, which certainly wouldn't be good. But I've got this built heavy duty enough. I've got it heavy enough that I can park my Rhino on top of this and such. So it's not going to move much, and I'm going to stay toward the corners. So let's take a look at this. Start out by making sure that everything is level, and it is. Turn on the power. Step back and check it for level. Looks good. And it looks off just very slightly that way. There we go. Make sure that my detector is turned on. Get out the tape measure and start measuring. Start on this corner. And I'm reading 10 5/8. Go to this corner. I'm reading 10 11/16. Now here, I'm reading 10 5/8. One more. And I'm reading 10 5/8 there. So that far corner is, which would be the south corner, is a 1/16 of an inch low. So we're good for grade. Now for checking for square, there are a couple of things that we can do. I'm going to take you back to high school math. I know you'll enjoy that. In algebra, probably one of the first things that we learned was the Pythagorean theorem. I know that's of interest to everyone. The Pythagorean theorem, let me see if I can get this right, says the length of the hypotenuse equals the square root of the sum of the squares of the other two sides. I think I got that right. So in construction, something that's real commonly used, just for a starting point anyway, is if we have one side that's 3 feet, or actually it can be any unit, it can be inches, feet, yards, whatever. but I'll say feet. We go 3 feet on one side, 4 feet on the other side. What is the length of the hypotenuse? It's actually a pretty easy formula. 3 squared is 9, 4 squared is 16, 9 plus 16 equals 25. The square root of that is 5. So it's a 3, 4, 5 triangle. That's one of the things that we can do using the Pythagorean theorem, and we're going to try that. So on this sheet of plywood, I will mark 3 feet, and I'll go 4 feet this way, and then I'll measure across the diagonal. And I have right at 5 feet. Now that's fine and dandy, but on something small or something larger like this, all that has told me is that this sheet of plywood is square, has the edges square. Like I say, we can use that on for feet, inches, whatever. And we'll go to yards. This time we'll go 3 yards in this direction. So I marked 9 feet. We will go 4 yards in this direction. And I will mark 12 feet. And now I will check that diagonal. And we have exactly 15 feet. So using the Pythagorean theorem, we have a square surface here. Let's make everything in feet. And I'll convert inches into decimals to where we are using, instead of using inches, we are using hundredths of a foot. And 1/100th of a foot is approximately the same as 1/8 of an inch. So in converting to feet, this 11 foot, 1.5 would be 11.125. 11.125 squared, I've already checked this and written it down, is 123.77 feet. The 12 foot 8 inches is 12.667. That squared equals 160.45. The sum of those two is 284.22. That should make the square root of that 16.85, which is 16 foot 10 1/4 inches. Let's see what we've got. We have 16 foot 10 1/4 inches. We just checked that one to be 16 foot 10 1/4 inches. Let's check this one. (16 foot 10 1/4 inches). So this deck is perfectly square. It is level, with the slight exception of the one corner. So we have something that's a really good base to work from. We're going to get started framing some walls. I'll frame this one first. Probably the back one there second. And the reason I want to frame this one first is these walls are going to be too heavy for me to lift. I will build them here on the deck and then stand them up. I've got this tree and that tree to where I can winch them up into place, so that'll make this one an easy one to set first. I've got that tree, which I don't know how much I can depend on it, but I'll be able to lift this one second, tie the corners together, and then go to this corner here, which I've got that hackberry tree that'll maybe help me some. It's going to be pretty heavy, but I'll give it a shot. And then I'll finish out with this side here, which is going to have the 8-foot wide by 7-foot high door to where I can actually drive in and park on this. That's what we're going to do. We'll get started with some time lapse. Ready for plywood sheeting on this, which I don't have, so I'm going to need to take Gabby and we need to go down and take a run to the big box store and get some plywood. One thing I'm going to do before I do that is, as I said, I'll be pulling from the top of this wall to somewhere in this tree here in order to raise this. Right now I could probably handle it by myself just fine, but once I add plywood to it, it's going to get kind of heavy. I see one stud that I forgot to nail in that I need to get to. But then, as I'm trying to raise it, the wall is going to want to try to slide this way. So what I'm going to do is take some double-headed nails that I can pull later or just leave in. And I will toenail these. Excuse me, Gab. Toenail this wall to where hopefully that doesn't happen. Now I need to check the wall for being square, because if my deck is level, I put that wall together square and all the sides are parallel, the diagonal distances should be the same across here. Let's check them and adjust them to where they are before we put the plywood on. And we'll double check it one more time when we come back with the plywood. It is real close. Close enough that I can adjust it when we start with the plywood. I'm going to call out these two distances, the length, which I guess we already know is 12'8", and the height. And if my daughter, my 15-year-old daughter, who should be in school right now, is listening, use that Pythagorean theorem to tell me the distances that I just read. There's a challenge for you, young lady. The height is 7 foot 5.5 or 89.5 inches. Little girl, tell me what I read. Gabby and I will be back with plywood. As I get older, I get weaker and wiser and have a great deal more respect for my back and what all my joints mean to me. So even though I tried, I think I probably could raise this wall myself, I don't want to. I think I'm set up to use this rope come along to raise it up. If it ends up going too far, it's just going to lean back against a tree. That's not a problem, and I don't think it'll go too far anyway, because I've got about a 6-inch overlap on the plywood here. This base plate is nailed in 3 or 4 places, so once it hits that, I think it'll stop, and I don't think my come along is rigged high enough to be able to get that far anyway. So what I'm going to try to do is to stand this wall up to a near vertical position, and then put a brace on each corner. And what I'll do is I'm actually going to leave it leaning outward just a little bit, which will make my next wall easier to stand. So here we go. You can help me raise this wall. Gabby wants to help too, I guess. I have the drone hovering above, so pass or fail, we're going to get a couple different angles on this wall going into place. This rope come-along is probably one of the coolest tools I've ever purchased. I've used cable come-alongs, I've used strap come-alongs, and you always go until you run out of cable. With a rope come-along, you're only limited by the length of the rope, and you just keep going, and going. And like I say, it's probably the coolest tool I've ever purchased. It's rated for 750 pounds, although I've lifted about 1,000 with it already. If you're at all interested in the purchase of something like this, I got this on Amazon, and I'll include a link below as to where I got it. Here we go. Yeah, you're going to have to watch out there, Pete. At some point, you're going to have to get off of there, Dan. Good morning, I'm back. I'm going to close out this episode just with a little bit of an overview of the importance of starting right, and mathematics can be a part of that, as boring as mathematics are to most people. I'm actually quite fascinated by it. The understanding of the concepts of square, level, and plumb are pretty darn important. And relating back to how some of the old timers did it, let's start with square. Framing squares have been around for a long time. I don't know that many or any of the old-timers even heard of the Pythagorean theorem and how to use that, but they were aware of the concept of diagonal distances making a building square, in that if you have two parallel sides here and here, the diagonal distance here should equal the diagonal distance there. So I suppose not surprisingly, most of the older buildings that I have restored have been pretty square. So that's a good starting point. The concept of level then, in framing and interior construction and such, we want to start with a level surface. It makes the rest of the job a lot easier, but to me is probably one of the least important concepts in the basics. And oftentimes with concrete work, in order to get drainage, we intentionally make things out of level, build things out of level. Roofs, of course, are out of level so that they'll drain water. The concept of level is perfectly horizontal. The concept of plumb is perfectly vertical. And to me, that is probably the most important one, especially where we have loads coming from above on that vertical wall. The human body, as we stand basically vertical. If we are out of vertical for very long, we start putting stress on our calves, on our feet, and it becomes very noticeable. If we have a horizontal surface that is out of horizontal, it can be out a little bit, we may not notice it, but it doesn't have to get very far out of horizontal to start noticing it. So far as plumb and how it relates to building walls, as we stand vertical, we are able to withstand a pretty good load. When we lift a load, if we lift it vertically and our bodies are vertical, that produces the least amount of stress on our bodies. If we reach out to pick up a load, it's pretty obvious that we can't lift nearly as much leaning over and reaching out as we can if we're picking straight up on it. Same stands for a wall. If a wall is perfectly vertical, it'll withstand a much greater load than if it's leaning, even just a little bit. The farther out of plumb something gets, the less load, vertical load, that it's able to withstand. When we look around at old buildings that have been around for a long time, those that are near the state of collapse, if the walls on it are vertical, typically what will happen is that the building will cave in pretty much straight down. If we have walls that are leaning, which is, it happens very often, especially after time and some deterioration, generally when they collapse, they will collapse in that fashion. So even though spending the time with this may be boring, it may seem very obvious to some, and if you've been in construction for a long time, you probably just want to blow right through this episode. But if you're a beginning homesteader, don't know an awful lot about building and construction, those basics of square, plumb, and level are actually pretty darn important. And they'll make your life a lot easier for you. Going back to square, one other thing I'd like to add is that back in the old days, square probably didn't matter nearly as much as it does now, because boards came in random widths typically and random lengths. So if you're framing something and you just take your board to the center of the next stud or joist or a rafter and cut it off there. Today we deal with oriented strand board or plywood that is sold in 4-foot by 8-foot sheets, and if we're out of square, we pay for that in a hurry. We nail one edge down and that works good, but by the time we get to the other end of the rafter or stud or whatever, the plywood may not have anything to nail to. If we try to cut a sheet of plywood to fit our out of square nature, then we're going to be short on the other side. So life is a whole lot easier to start out with square. I'll close out this episode saying I hope you learn something from it. The importance and really the urgency of starting right just makes your life a whole lot easier. It gives you a better structure, something that's more pleasant to look at. And there we go. If you like this episode, give me the thumbs up. I really appreciate that. Subscribe if you haven't already. Ring the bell if you want to be notified of future episodes. I appreciate that. And please share with a friend. I would really like this to be watched by more than just a few people. Make it worth my time. So thank you, and until next time.